Are you looking to build the best budget gaming PC you can put together right now? If so, you've come to the right place. I'll be showing you how to assemble a sub $700 gaming PC that still slaps for 1080p gaming. We're talking 60 to 100 frames per second in all the latest titles. I'll be walking you through the parts that make it possible and taking a deep dive into performance a little bit later. Let's do this. Let's kick things off by taking a look at our GPU and CPU combo first of all. For the graphics card, you can select either the AMD RX 6600 XT or the standard non-XT version. You're going to find around about a 10% frame rate hit in it, but there are some serious cost savings to be had with the 6600. While Nvidia's 3060 is also a great bet for builds like this, AMD cards in this area are plainly cheaper to buy, and with fantastic rasterization performance, they actually tend to perform better in games like Fortnite and Call of Duty Warzone on a $ per frame rate basis. While you lack features like Nvidia's DLSS and ray tracing, and the AMD substitutes aren't quite as good yet, for raw gaming power with none of the fancy add-ons, these are still an awesome choice. Plus, with 8GB of GDDR6 video memory, a card like this has got plenty of VRAM, avoiding the mistakes AMD themselves made with their admittedly terrible 6500 XT, and giving you a slight VRAM upper hand over the other alternative cards. Plus, all the GPU rumours that we're seeing seem to suggest that budget cards like this will not be getting replaced anytime soon, at least not this year, so if you're looking for a great build to put together now, around Black Friday or Christmas, this is a fantastic choice. I'll be pairing it up with the Intel Core i3-12100F. Now, an i3 chip for a graphics card like this seems, on the face of it, a little underpowered. But in our testing, we figured out that the i3-12100F is actually good enough to stand up to these GPUs. The i5 is a worthy upgrade for another $60 or $70, but personally, for gaming, this is the better choice. With fantastic clock speeds and Intel's latest performance cores, and 8 threads for good multitasking performance, it ticks all the boxes. And once again, without sounding like a broken record, CPU rumors seem to suggest that more i3 chips or Ryzen 3 chips, which are your AMD alternatives, are not going to be landing this year, making this build really a little bit future-proofed right through into 2023. We'll be installing our i3 into one of my personal favourite budget motherboards. In our testing, this scored incredibly well, and it's Gigabyte's B660 DS3H-AX. Buying a motherboard for Intel 12th gen CPUs can be a little bit of a minefield to say the least. Some boards support newer and more pricey DDR5, this one doesn't and sticks with cheaper DDR4. Some have Wi-Fi and some don't, this does, helping you to get set up out the box with no need for a pesky Ethernet cable. And some boards plainly lack the kind of features that you'd expect at a price point like this. 12th gen motherboards are admittedly quite a bit more expensive than the current Ryzen alternatives, so be careful which board you pick. Now, this board is absolutely stacked with features. As I say, the main ones for us are Wi-Fi, the addition of PCI Generation 4 with a couple of slots here, and support for cheaper DDR4 memory. Installing one of the not so new 12th gen processors is actually not too tricky. Locate the triangle on the socket and match this up with the golden triangle on the underside of your processor. Lift up the arm, release the socket top, and then nice and simply drop the CPU into place. Give it a little bit of a wiggle, and then we can pop the cover down and add our retention arm in for good measure. For a build like this, where value for money is one of our most important metrics, picking up an aftermarket cooler for $40 or $50 is plainly a waste of money. And with great airflow in our case, 200mm fans to be specific, which I'll come on to shortly, enough airflow is not a problem either. That makes sticking with the humble Intel stock cooler actually a very viable option for this build. With a new redesign for 2022, which includes a black and blue aesthetic that actually looks really nice, and an easy installation method, you can't go too far wrong. Don't believe me? Check out some of the temperature numbers we pulled in our benchmark section later to show just how well this is actually doing of keeping our humble humble i3 cool. Click it in corner by corner, add in your 4-pin PWM fan header to the CPU fan port, that's the grey one, and you're pretty much good. Plug it up to the wrong port and it will still cool the CPU, but your motherboard may spit out errors, worrying you haven't gone ahead and installed a cooler. So pop it in that port and that will make your life just a bit easier. While we're here, we can also add in our RAM or memory. I've gone for a 16 gig kit, 2 8GB DIMMs to be precise, of Corsair's Vengeance RGB SL. Now, any of the Corsair Vengeance kits are going to work well. I'd opt for a 3200 MHz kit or higher. 3600 is going to work well for this build. And while Intel chips aren't quite as picky as AMD when it comes to RAM speed, they are still pretty reliant on decently clocked memory, at least with 12th gen, where DDR5 is obviously delivering higher speeds for the boards which support it. Slide your RAM into place. Make sure you do this with the Corsair Vengeance logo facing away from the processor and click it in. We'll be using the lighter of the slots, the light grey as opposed to the black ones. It's slots 2 and slots 4, the furthest 2 alternate slots away from the processor. Finally then, we've got one more part to add in to our motherboard assembly before we can go ahead and look at the case choice for this build. A component I've used a lot before, but not particularly recently. For the SSD though, I've gone for the Samsung SSD 980. Not the Pro, not the Evo, just the bog standard 980. It still gives you read speeds of up to 3.5 gigabytes per second, and it's a drive that we think is one of the best budget options out there right now. Or at least it was before it fell out the box onto the floor. Luckily for us, this is a solid state drive and not a hard drive, so with no moving parts, it should theoretically be a-okay and shouldn't be breaking anytime soon. Go ahead and locate the tiny little screw on your motherboard that comes pre-installed onto the standoff. Take this out and then we can slide the drive in. You want to tilt it in at a 45-degree angle before pushing it down and securing it into place with the same screw we removed earlier. Power and data will both be passed through our M.2 slot, so no SATA cables of data or power to worry about, keeping cable management to a minimum and making things a bit easier, shall we say, for the first time or rookie builder. Now then, that case I alluded to just a moment ago that I'm quite so excited about. This is the Aero Cool Hive. The name being the Hive because the front, in theory, looks like a beehive. This is one of the best budget cases you can buy right now. I think I picked it up for the equivalent of about $43, making it a fantastic budget shout. With inflation and the cost of materials and stuff, very boring for the channel, I know. Cases are going up and they've been some of the worst affected by that situation. GPU and CPU prices have been coming down for a while. Cases have been going the other way, so be careful and shop around. You want to remove all the side panels. The back one's now off. I took the glass one off earlier, and this will make accessing everything to do with the case quite a bit easier. As with any build, I'd recommend you lay the case down flat, and that's why it's important to have a clean and large work area when building a PC, especially for like huge cases like Cooler Master's have 700 Evo. It would dominate any table, and once the case is completely flat, we can then go ahead and install the motherboard. But wait, because this is a budget system, we haven't got a fancy board with a nice built-in rear I/O shield. We instead need to opt for the very default, slightly sharp, slightly prickly metal one that comes included in the motherboard's box. What we're going to do is we're going to slide this into the case from the top, and then at the rear you should see it start to poke through. Do your best to clip it into each corner without cutting your fingers open. As I say, it can be sharp, so be careful. And then after that's done, we can slide the motherboard in. A cursory glance at all the standoffs on our motherboard tray looks good. For an ATX board, you need the 3 at the top, 3 across the middle, and 3 down the bottom. But smaller motherboards will require different standoffs and different holes. So always check this before going to Gonco and installing the motherboard. Be careful with an ATX case as it is quite a tight fit. Slot those ports through the rear I/O, and then in theory, it should line up with all the standoffs like so. Screw them in. I'd always start from the middle and work my way outwards. Do an even split. So don't do all the ones at the top before doing the middle ones, one from each row. Take it step by step and give them a nice tighten at the end once you're confident they're all installed. All the screws you need for this stage will come included at the rear of your case with any chassis that you buy. At this stage of proceedings then, we can go ahead and install our 6000 series GPU. As I mentioned earlier, this is going to be a great choice. The 6600 XT is a slightly better shout if you've got the money, but the 6600 non-XT is also going to be awesome. As I say, you're looking 10% if that in the frame rate, making either of these these cards an awesome bet. We're going to push down the retention clip on our PCI slot just here, and then we're going to make sure that these PCI lanes, which have been removed from like a previous build, are in fact the right ones to have been taken out. So if we hover it over, that looks, double check, exactly right to me. If they are the wrong ones, then you can go ahead and remove others. These are the horrible single-use ones that you then can't reinstall if you get it wrong, so just be careful and double check that your main PCI slot is lined up with the GPU before taking out the rear lanes. Once you've done that, you can slide your graphics card in. This triple fan Gigabyte OC edition fits in without a problem, still plenty of room on the side here, for even like a radiator if you wanted an all-in-one. Apply a bit of pressure, and the GPU will click in nice and easily. If you want to check or you're not sure it's quite seated properly, give it a gentle tug upwards, and if it doesn't come out and your motherboard is flexing, it is tied in and latched a-okay. Just don't pull it too hard, as you could cause some serious damage. Pop in a couple of screws to fasten it down, and then we can give it power in the next step of the build, where we look at the power supply choice for the whole system. The component responsible for getting the juice from the wall and splitting it out into the right formats for all of our components is the Coolermaster's MWE Gold 650V2 fully modular. The name's a bit complicated, but let me break it down. 650 watts of total output, which is fine for our graphics card, CPU, and other components. Heck, even maybe an upgrade later on. Fully modular means you only plug in the cables you need, and that will give you loads of spares, which you should keep a hold of in case you do upgrade later and need more cables. It also reduces cable management, which makes your build a bit more sleek. Finally, the fact it's gold rated means it's very, very efficient. It wastes a very little amount of the energy it takes from the wall as heat or noise or basically anything wasteful. Something which in the current energy climate is actually a really good thing. If you take a look at the power supply itself, it's a pretty compact standard power supply brick size with your modular interface here for plugging in only the cables we need. In this build, we'll be plugging up a cable for our motherboard, GPU, CPU, and SATA. Now, SATA power is just going to be for powering the RGB and fan controller included on Aero calls Hive as standard. Then we can go ahead and add in the power supply by screwing in the 4 screws at the rear and plugging up the CPU power connection to the top left, motherboard to the right hand side, GPU to the graphics card, and our SATA power cable to the RGB hub. Take these step by step as they can be a little bit fiddly, but will all go into the right places and can't be forced into the wrong connectors. And then once that's done, we're basically ready to boot the system up and see how it performs. We'll be testing a wide range of titles, starting off with the likes of Battlefield 2042 and then working through to Apex Legends and Fortnite. In Battlefield, we tested at 1080p high settings and measured our frame rate with both MSI Afterburner's Riva Tuner and Nvidia FrameView as usual. Here we managed to achieve 81 frames per second on average with strong 90 and 99th percentile results for good measure, and received a really enjoyable playable gaming experience. This number fell very slightly short of our recent 3060 Ti build, a much more pricey system, showing how perhaps this PC is punching above its weight. In the new F1 title, F1 2022, we also tested out at 1080p, but this time the ultra high settings preset. We pulled in here 78 frames per second on average to just shy of 80 frames per second, with consistent 90 and 99th percentile results that more than tick the box for what we needed at 1080p in a racing game. Spiderman also delivered strong results too, 1080p high settings in this title. We managed to achieve nearly 90 frames per second for the average and well over 60 for our 90 and 99th percentile results, and the game looked, to be honest with you, pretty fantastic. Swinging through all of the buildings and that kind of thing is just such a unique playing experience and so different to everything else on our list today. The good results carried on rolling through though into some of those slightly older titles, with Apex Legends bearing significant fruit for our Team Red AMD graphics card. Here at 1080p high settings, we got nearly 180 frames per second on average. This really is a lot when compared to some of the Nvidia alternatives, which tend to cap out at that 140-150 FPS mark. 180 in Apex Legends at high settings creates a very, very playable gaming experience, and the title looked fantastic. Our penultimate game today is Valorant, bit of Valorant tested at 1080p high settings here, and frame rate is surely one thing that wasn't in short supply. 354 FPS on average delivered fantastic results. Valorant is quite an easy game to run, but you guys like to see it tested to make sure all of our builds stack up with this very popular esports title. Finally, to wrap things up, we also tested out Fortnite at 1080p competitive settings, where once again, Team Red did deliver. 233 FPS on average at competitive settings, settings, around 30 frames per second higher than a more pricey 3060 Ti, and about 50 frames per second higher than the comparatively priced 3060. Fortnite is just one of those games where AMD seem to excel. I've got no idea why, but the results were fantastic, and the game looked absolutely awesome. That wraps it up for the benchmarks and the entire video. If you did enjoy it, drop a comment, drop a like rating, and maybe even get subscribed. Thanks for tuning in, and as always, we'll see you in the next one.